Yeah, this is just a double replacement reaction. So what we're going to do is we're going to go silver chloride. We're going to form silver chloride. Formula for silver chloride, AgCl, and nickel 2 nitrate. Formula for nickel 2 nitrate, that's right. All nitrate salts are soluble. However, not all chloride salts are soluble. Silver, lead, mercury form insoluble chlorides. And so this is an insoluble chloride which will precipitate. So that's the driving force for this reaction, is precipitation of silver chloride. So what we want to do is we want to get into this. This is the mole ratio here. Actually, this is not balanced, so we don't have the mole ratio just yet. I need to balance this first. So I have one silver, one nitrate, 2 nitrates over there. So I'm going to need 2 silver nitrates, which means I'm going to have 2 silver chlorides. And now it's balanced. This is balanced. And so what I want to do is I want to get into the moles here, the mole ratios here. And so I'm starting off with 503 milligrams of silver chloride. So I'm going to put that down here, 503 milligrams of silver chloride. And then what we're going to do is we're going to go from milligrams of silver chloride to grams of silver chloride, just by using the relationship between milligrams and grams. And then grams of silver chloride, I want to get to moles of silver chloride. And so whatever I can do to get to moles of silver chloride, I need to do. And then I can relate this back to, what are they asking for? Nickel 2 chloride. So they want us to relate it back to nickel 2 chloride. So I'm going to go from moles of silver chloride to moles of NiCl2. And then from moles of NiCl2, they're asking how many milligrams. So I'll get grams of NiCl2. And from grams of NiCl2, I'll get milligrams of NiCl2. And this is it. And so what we need to do is the stoichiometric ratios are these mole ratios. So we just need to get it into moles, and then we can relate it stoichiometrically. And so the way we're going to do this is by dimensional analysis. We need conversion factors for it. And so 503 milligrams of silver chloride, just put it here, 503 milligrams of silver chloride. And so we'll go from milligrams to grams. 1 gram is 1,000 milligrams. So that gives us grams of silver chloride. Once we're at grams of silver chloride, then we want to get moles of silver chloride. So we'll need the molar mass of silver chloride. Let's take a look at the periodic table. Close my periodic table. Let me get it out again. Okay, silver, if I look at that, you see it? I see it. It's over here. It's hard to read. Silver, Ag is 107.87. 107.87. Let's figure out the molar mass here. Ag 107.87. Chlorine, which is off to the side there, is 35.45. And so, getting the mass of silver chloride, just add these two up. It's going to be 2, 3, 43, 32. So 1 mole of silver chloride formula unit. Silver chloride is an ionic compound. It doesn't form molecules. So 1 mole of AgCl units weighs 143.32 grams. And so this will allow us to do a gram to mole conversion here. We'll go from grams of silver chloride to moles of silver chloride. Okay, once we're on moles of silver chloride, then we can just use the stoichiometric ratios to figure out how many moles of NiCl2 we need. We're going to have 1 mole of NiCl2 for every 2 moles of AgCl. And so 1 mole of nickel 2 chloride is consumed for every 2 moles of silver chloride that's precipitated. Okay, now we are going to need the molar mass of NiCl2. So we'll need nickel here. Nickel is 58.69. Nickel, 58.69. And then we have 2 chlorines. 2 chlorines is going to be 70.90. So we'll just add that up. 2 times 35.45. This is going to give us 9, 15, 9, 12, 129.59. All right, the units for these, since there are 2 ways of looking at these masses. One way is grams per mole, the most common unit. The other way would be U per formula unit. We're using grams per mole in stoichiometry. And so this is going to be 129.59 grams per mole. So 129.59 grams of NiCl2 per mole of NiCl2 formula units. All right, they don't want the answer in grams, they want the answer in milligrams. So we're going to have to do one additional step here to convert grams to milligrams. So there are 1,000 milligrams per gram by definition. And so all the units should work out. So I just need to do the calculation here. I'm multiplying by 1,000 and dividing by 1,000, so I'm just going to cancel out the 1,000 there. All right, so calculating this, I get 503 divided by 143.32 divided by 2 times 129.59, 227.4. So 227.4 milligrams of NiCl2 were required. So I need 227.4 milligrams of NiCl2, and that reacts, and this reaction will yield 503 milligrams of silver chloride AgCl. See what the book did. The book did some shortcut steps. So what the book did was they went from milligrams to millimoles using the millimolecular mass. But I always like to go to the same place, So I don't like to change things around too much. And so for me, the heart of the stoichiometry math is a mole to mole conversion, not a millimole, even though millimoles are kind of the same thing, just smaller. I like to go mole to mole. So I don't like to take these kind of shortcuts. That way I end up consistently at the same place each time. But, I don't care how you do it. You could do it any way you want. And so they get the millimolecular mass. The millimolar mass is going to be milligrams per millimole. It's the same number, but I don't like to do that because when I think of molar mass, I don't want too many units I have to keep track of. Here are 2 units you definitely have to keep track of, grams per mole and U per formula unit. Enough already. I don't want any more. Then they have the balanced chemical equation, which is the same as we got. And then the mole ratio, but they're taking the millimole ratio rather than the mole ratio. And then they get the millimolar mass for nickel 2 chloride. And they string it all together. So theirs looks a little longer. Theirs looks shorter. Mine is longer, but I don't mind. Mine is longer, but it doesn't bother me. So I don't really use millimoles and millimolar mass. But you could do it any way you want. You get the same answer, 227. They rounded it to 3 sig figs, which were allowed. So 3 sig figs here, 4 sig figs here, 4 sig figs here. So this should round to 3 sig figs, 227 milligrams NiCl2. This is just a rough, qualitative calculation. 500, times 130 divided by 143 is about 1 divided by 2. So that's what they're doing here. Okay, so let's try out the calculation. Sample calculation. This will just be a stoichiometry calculation, standard stoichiometry calculation. So, let's look at the combustion of methane. Methane, what's the formula for methane? CH4. If we combust it, we're reacting with what? Oxygen. Methane's a gas. Oxygen's a gas. What do we form? Yeah, carbon dioxide, which is also a gas, and water. Water is not a gas. The water is going to be a liquid at room temperature. Is this balanced? No. Can you balance it? Two oxygens and 2 waters? Okay, that's correct. Then it's all balanced. So when we're dealing with moles, it's easy to see. For every mole of methane combusted, how many moles of CO2 form? So if I burn 1 mole of methane, I am going to form how many moles of CO2? 1. It's a 1-to-1 mole ratio. That's it. But moles, do we actually measure moles? We don't really measure moles. And so what we might say is, we might frame it like this. If I burn 1 pound of methane, and so 1 pound of methane, how many pounds of CO2 how many pounds of CO2 will be produced, or should be produced, from the combustion of 1 pound of methane? And so why don't you try this? Is it going to be 1? If I burn 1 pound of methane, will I get 1 pound of CO2? No, actually not, because even though I'm forming 1-to-1 mole ratios, they weigh different amounts. Methane weighs a different amount than CO2. So what you'll need is this. Do you remember how many grams are in a pound? 453.6 grams in a pound. How many sig figs is that good to? How many sig figs is this good to? 4. If you need more than 4 sig figs, you just look it up. In fact, you don't even have to look this up. This is going to be given, but typically 4 sig figs is enough for most of our calculations. So that's okay. You'll need the molar mass of carbon. A lot of people have this memorized because carbon's such a common element. Do you know the molar mass of carbon? 12.01. Hydrogen is very common. What's the molar mass for hydrogen? 1.01. Oxygen is very common. 16.00. Those are the ones. And so can you go ahead and tell me how many pounds? For every pound of methane that's burned, how many pounds of CO2 form? That's all.